So actual fact, apologies on the outset. I thought that this was going to be a little bit more of a sort of Q&A, kind of closer thing, and they told me it's going to be more lecture format. And I'm a little bit unprepared for that, but that's okay. I used to lecture physics, and I'm used to boring large groups of people, so hopefully we should be in good place. I did introduce Citadel a little bit this morning, but actually I'm kind of curious, just show of hands, before this morning, who even knew like who the hell we were? Actually, not bad, not bad. Okay, not better than usual. All right. A rough idea of who we are. I mean, I talked a lot about this morning, but obviously we're a hedge fund. We've been in business since 1990, and I sort of gave some stats this morning. 24 billion under management in our asset manager, and Citadel Securities makes up a significant fraction of the U.S. equity volume every day. And we're based out of Chicago, but we have offices all over the place. I have a feeling these are old slides. Interesting. Did you get my latest ones? Okay, thank you. Just check that. All right, we'll keep going, and then there might be some interesting moments here. One thing I didn't talk much about this morning, though, was we have a lot of different businesses. So we deal in securities and equities, commodities, credit, and then we have a lot of different groups dealing with that in a lot of different strategies. So we have a lot of quantitative strategies, we have a lot of sort of big PMs and that kind of thing. So we have this like big collection of groups all looking at financial data in a different way, right? So these markets, the way that a credits team might work is totally different to the way an equities team might work, right? So we have a lot of different types of workloads, a lot of different types of compute that we do, and we're ever growing, right? We have an ever-growing areas of interest. We have, a growing footprint. And back in 2015, when I joined, there was an obvious need for an awful lot of extra compute, right? One of the biggest problems we face as the infrastructure team is we sit there at the bottom of the stack, if you kind of see what I mean. There's all these app teams above us. We're not dealing with one particular problem. We're not like a advertising agency that's just worried about clicks and hit rates and things like that. We've got radically different teams above us doing their compute in radically different ways and thinking about their problems very, very differently. So we needed a platform that was essentially as flexible as our businesses are varied. So when we were reevaluating how we were going to do compute go forward, we had a bunch of requirements that we needed. First of all, we had to be able to source our compute. So we obviously have, like everybody, we have a certain amount of compute ourselves. But as we grow and our research grows and our areas of interest grows, we needed an awful lot more. The sort of general kind of use case that we're dealing with is that a quant or a researcher or something might want to very quickly run a back test of a model. So we had these very, very high burst workloads, right? Nothing's happening, bang, we're straight up to full capacity. So we also tend to be rather large. That full capacity is not uncommon to be about 100,000 cores. These are definitely old slides, by the way. So obviously, building a data center for that kind of capacity and especially that kind of bursty workloads is not really feasible, right? So the public cloud is the place we would want to be. Now, when we were thinking about moving to the public cloud, one of our requirements was that we wanted to be somewhat vendor neutral. By the way, the speaker clock isn't working down here. I have no idea how long we're running for. And the reasons for that are multifaceted. The primary one is we want to mitigate future risk, right? It is not an option if a cloud vendor has some sort of global outage, which is not unheard of for 20 minutes or half an hour. It's not an option to just say, well, it's okay, we just can't do that right now. So we needed to hedge that risk, essentially. That's what we do, right? The other one is essentially basically means leveraging the opportunity that particular cloud providers can afford us, right? So if a business comes along and says, you know what, this cloud provider over X over here has got a really awesome thing, it's going to be really fantastic for our business, we don't want to just say, well, we're kind of like in cloud provider Y right now, and we've got all our stuff here, and it's going to be a major technical thing for us to get all the bits over there that to make this thing go, right? So we want basically the choice of cloud provider to be driven by the business and not by technical requirements, okay? So we want to leverage those value-add tools that cloud providers give us, but not necessarily get completely locked into them, right? Difficult balance. Obviously, also less important, they have different regions around the world, and one vendor might have a region, or provider might have a region that we want to leverage for certain reasons. We want to be able to go there, so that's another thing. And lastly, and most importantly, when you're talking about 100,000 core scales, there's a bit of a capacity issue. If you've got multiple teams who want to run jobs like that, right, we're going to have to spread that load a little bit, okay? So we actually currently spread our workloads over 3+ cloud providers. We need a platform that could run in any and all those providers. A little bit about rate of scale. So I've said that we have some large jobs, but I think we're not Netflix or Google or anything like that. But I think one of the things that really sets us apart is the rate at which we scale. So if you go and ask a business person, like they're going to put a job in, they're reacting to something in the markets or some idea they've had, when do you need that job by? They'll always say immediately, right? Now, right? If you actually drill down a little bit on that, though, usually the sort of time frame is minutes, right? So they need to do, got a pointer here? Yeah, there we go. They need, if you look at sort of basically the compute capacity, they need the whole job to be done in, let's say, 30 minutes. That's actually quite long, but let's say 30 minutes. And they need a certain amount of compute capacity to happen in that time, right? So just by looking at that plot of cores versus time, obviously, now there's two things that really matter, right? There's essentially how long it takes you to get going, this delta T, and how quickly you can start provisioning that footprint, right? So the number of cores by time, right? DC by T. And there's really no reason not to go wide in a public cloud provider, right? I mean, it's the same cost if I run one thing for 1 hour or, 100 things for 1 hour or 100 hours for one thing. It's basically the same cost. So, for us, the real magic numbers are damn it. Here we go. Delta T, how much time it takes us to get going, which is usually not such a big problem, but can be for some schedulers. And DC by dt. Okay? We have, as I sort of alluded to, the diversity of our teams means we have a very diverse set of workloads, right? Honestly, the majority of our big workloads, our big data processing workloads, are batch. I think that's no secret. But we also have a lot of streaming workloads, where we have stuff being dumped into queues and big compute node, farms of compute nodes pulling off that thing and processing it and sending off somewhere else. And then we have some stuff which is sort of like a MPI-like and Spark and sort of various different stuff. So we needed a scheduling environment that could treat all these kind of platforms as equal citizens, right? That we could, if we need to schedule a batch workload, we can schedule a batch workload. If we need to schedule a service that's setting off a queue, we can do that and have the option to sort of support some of these things in the future. So a little bit about job deployment. We have all these application teams, these groups, right? And they're writing their jobs and they're changing them all the time, right? It's very, very quick turnaround. They'll have an idea in the morning. They're pushing that into a back test in a few hours, right? We're not involved in that, so we have to get out that way, right? We have to completely get out the way. And because it's changing so quickly and they have so many arbitrary dependencies in their environment and things like that, obviously this feels like a kind of good thing for containers, right? And I'm not going to go into the whole CI/CD pipeline, just take it as read that that's kind of something we do, but I'm not going to talk about it right now. So just assume that these guys are building applications in containers and pushing them to our environment, right? So I don't know how many of you have started doing this with your dev teams, but what's the first thing they do when the first container they build, right? Freaking enormous, right? It's multi-gigs in size, right? And then they put it into the orchestrator and they say, well, why is it taking so long, right? Because, well, you've got a 25 gig container. So even if you put a lot of work into slimming down these sort of heavy data processing applications, you're still kind of ending up like 100 megs, basically. Kind of rough gut feel. So just do the math, right? I mean, if I'm starting up 20,000 of these, right, that's actually a fairly major piece of infrastructure just to feed those cores with those containers, those images, right? Because we're going from 0. There's no images baked in. There's no container images baked in. There's no layers baked into the images. We're starting from 0 straight up to, let's say, 20,000 cores with nothing, right? So we've got to get it out to the compute quickly enough. And the last thing, which some people are always a little bit surprised about, which is kind of odd, is we're hyper cost sensitive, right? We're very good at understanding the value of things, right? And what's our business? Our business is to make money for our investors, right? So every dollar we spend on compute is a dollar we don't make on the other end, right? So we're very, very aware of our costs of this compute, and this is some serious size. It gets expensive, right? Additionally, I should say, is that once you enable your application teams and your researchers, I don't know if anyone's had this experience, essentially unlimited compute, they manage to use it all, right? So you do really have to there's a lot of onus on us to keep those costs, driving those costs down, right? Actually, a little bit more word on cost. So how we essentially sort of do that is we make heavy use of these discounted pricing models, right? So these are just two providers I've chosen. Amazon has the spot market, if you're familiar with that. I mean, I don't know how many of you are familiar with this, but the idea is of all these providers is they auction off unused compute, right, at a heavily discounted price, but they reserve the right to take it away at any time, right? And how it works in every provider is quite different. Just to pick Amazon, because I can make a nice pretty picture of that. If you look at the cost over time, you can go and look at this on the console. This is some particular VM type, I don't know what, over 4 different regions. And you put in a bid, and basically, as long as you're in the money, you get the compute, and then, for whatever reason they need the capacity, they up the price, and if you're out of the money, your compute gets pulled away from you. Right? So that's essentially, a summary of our requirements when we were sort of like starting to look for a scheduler to underpin our next generation of compute. So we wanted to scale, smallest jobs are probably 10,000 cores, and then we go up from there, right? I'm not quite sure where the end of this is. Speed is probably the thing that really sets us apart. Is basically how quickly can we get it to that size, starting from nothing. We have to be vendor neutral. We've got an awful lot of different types of workloads to deal with, and of course we've got to keep it cheap, like the budgie. Okay? So what do we do? So we actually went out and evaluated a ton of schedulers. There's definitely all. Kubernetes, Mesos, Swarm, and we have our own internal scheduler. Essentially, what it amounted to was that they're all really good, and we actually use Kubernetes for some things internally. They were either unable to cope with the scale, unable to feed our compute quickly enough, or they didn't deal so well with the heavy churn rates that we have because of our preemptions, because of our spot instances. That's essentially about it. Or they weren't able to cope with like the batch workloads. Our own internal scheduler is actually very good at a lot of those, but it really has like some interesting features of single points of failure and things like that. So we were looking to replace it. So we started taking a look at Nomad. We're already heavy users of Packer, Terraform, and Consul, and they claim to have the scheduling rate and the workload diversity, but we have to check that out, obviously. So to do a simple test, this is what we were talking about this morning. We had a test container. I think it was about 250 megs in size, with essentially a configurable runtime. It was just sort of doing some work. We use our own tooling, which we've got lots of, to spin up 20,000 cores on GCP. And we ran, I think it was version 4.1, 3 Nomad servers, and then just started adding agents. I actually don't know how many we added, lots, I think. And I kept throwing 100,000 core batches into this thing all day long, and a few services here and there, but just kept filling it up. And then just basically by winding down the runtime, you can test your scheduling rate, essentially. So you saw these numbers this morning, 18, 20,000. It fluctuates a bit because we're getting some churn. We were able to push 2.2 thousand a second. And like I said this morning, it's about 5 hours. I actually don't remember how long it was, but most of the day. So, those requirements, it definitely was able to run, at the 20,000 core level, and I'm pretty confident that we're going to be able to push it up much higher than that. The speed, absolutely. It was able to feed our compute with by keeping up, basically, with our demands, It's got the vendor neutrality, though we have to dig into that a little bit, and the workload diversity. So let's go into vendor neutrality. So we have multiple cloud providers and on-premise. So on-premise, we actually harvest a lot of our unused compute. It's kind of like the same model as Amazon Spot or GCP preemptive cores. When they're not being used, we get to use them. So we just treat Citadel essentially as another cloud provider with its own pricing model and its own sort of peculiarities, right? Every cloud provider has their peculiarities. We're kind of like just another one, right? And by understanding the requirements of each job and the characteristics of the provider, we can actually route our workloads to the appropriate provider, right? So we actually built this thing that is called the Smart Resource Router. I think that's what they called it, yeah. So basically the idea is that the user submits a job to SRR specifying essentially proximity to data, the urgency, how quickly they need it, some maybe bespoke hardware requirements, things like that. And the SRR examines those requirements and then looks at various things in the market. So it'll look at like the cost of compute in Amazon, the cost of compute in Google, which is somewhat fixed, and what are essentially our internal availability. And also things like the recent speed at which we're able to get those cores. It makes some estimate of availability in all our providers. Like, well, I haven't been doing so good at getting cores from these guys. Well, let's back off for a little bit. And looks at our current footprints, right? So what are we actually running where? And then it directs workloads to the optimal provider and the optimal region in that provider based on the output of that analysis. And then when it's decided where to send it sends it off to the orchestrator, and the orchestrator places an order and watches capacity. So what that means is it understands the idiosyncrasies of each provider. So for example, in AWS, you've got a bid on Spot, right? So it understands, well, okay, I've got a strategy for getting Spot, best price of Spot out of Amazon, so I'll go and get that. Or if GCP, it's preemptives, or on-prem, it's something else, right? And it feeds back information back into the SRR on essentially availability, right? It sort of makes an estimate of that. And its other responsibility is basically keeping the footprint up, right? So if we're getting a lot of preemptives in Google or getting a lot of evictions in Spot, it's responsible for trying to replace that capacity. So the last piece of SRR is essentially the API, which this is a bit of crinkle. It provides some of the functionality that we're missing from Nomad, mostly sort of authentication and job tracking. So it understands, who can submit what applications and to where, and it helps them sort of keep track of it, which is something that I believe is now considerably better in more recent version of Nomad, which we haven't actually moved to yet. And it sort of feeds the SRR engine requirements, so it sort of translates the requirements into sort of requirements SRR can understand, right? And then couples, essentially, it talks to Nomad and submits the jobs to Nomad and couples the two together so that Nomad routes it to the right place. Right? So I'm not going to dig into this too much for obvious reasons, but the sort of rough architectural overview is we have our API sitting on the front end down in Citadel, and actually talks to our on-prem cluster. And we now have region forwarding, where it can essentially pass those off into different cloud provider, Nomad clusters, and different cloud provider, and the orchestrator then adds compute capacity to these guys. Right. So one thing I thought was worth just interjecting here, it's a little sort of an aside, but it's something that's worth noting, partly because we use Consul for it, but also I think it's kind of a common problem when people get up to our scales, is that you sort of, obviously we're a financial firm, we're not going to use like Docker Hub.io or whatever it's called, right? We're going to run our own. So you plonk this thing down in your data center and you use, like either the Docker registry or, core or whatever the other registries are. And the first thing that happens is you spin up a few thousand things and this thing falls over, right? Because like math, right? The math I did before. Especially when someone tries to ship a 30 gig container or something, it tends to sort of not go so well. So you have to actually, have a nice, scaling infrastructure for this Docker distribution. And the way we kind of did this is it's kind of a bit rough, but it does actually work pretty well. Is we actually use Docker Registry has like a pass-through option, a proxy option you can set. And we have it pointing back to our primary back there in each cloud provider. And as essentially the compute spins up, this thing spins up and is essentially an auto-scaling layer, and this thing spins up. These are the little caches, essentially the proxies. These things spins up to a few hundred or something, right, and register themselves into console. And as the compute comes up, these guys all have little console agents on them or whatever, and they fire out from console, well, give me Citadel Docker Hub or whatever it's called, and it round robins between these guys. So this actually works surprisingly well. As these things come up to tens of thousands of cores, we build up this caching layer, and we're now sort of getting the throughput we need. So it's kind of a nice little use of console in our environment. So dealing with failure. Failure is something we have to deal with a lot. Nodes fail all the time. You can have hardware blowing up on-prem. You can have AWS spot eviction, GC preemptive event, right? They all essentially pull the compute right out from underneath you. And you can also have a self-health checks fail. Every node is checking this sort of health and seeing if it's kind of not in a good state. The most common reason for that is disk filling. Our sort of cleanup of images is a bit of a kludge right now. Or the Docker daemon hanging. Apparently that's better in later versions, but we're on a little bit earlier version. And we get sort of the preemptive events are very bursty in their own right. You'll either have none or you'll get like 10, 15% of your infrastructure disappearing underneath you. You get about a 5% node failure for whatever reason on the individual hosts. If that happens, we just basically kill the VM and it's treated in exactly the same way as a preemptive event or a spot eviction. So what do we learn in this? Looks like I've got 3 minutes left, so it's a good time. So we ran we still run quite a lot of batch. We are transitioning much more to streaming processing and some architecture, but we still do run a lot of batch. And the Nomad batch model, if you give it to someone who's used to something like Condor or Slurm or something like that, it's a bit of a mental jump for them, the way they think about batch. So they have sort of questions, well, what's the state of the queue, and where's my argument list, and things like this, and sort of, well, it's just not really how it works, so you've got to sort of think about things a little bit differently. So there's a certain amount of re-education that goes on there, but generally it's working out pretty well. The way that people usually sort of feed their batch jobs is they essentially put an index into object store and then just pull directly from that using the Nomad index feature. And that's okay, but it's a bit clunky, but it does work. The job feedback as of the earlier versions was a little bit opaque to a batch user. I think when they're used to, using something like Slurm or Condor or something, they're just sort of a bit more used to sort of, well, here I am in the queue, and this is the percentage of jobs that ran, and this is the percentage of ones that failed, and so on and so forth. And getting that information out in a high volume environment was a little bit difficult. In 4.2, I think it is. Nomad person in the room? No? Okay, 4.2 then. That's considerably better. We haven't shipped to that yet. We're still on the previous version. Hopefully next week we'll do that, and that will take a lot of the pain out of our own API layer where we're trying to tracking internal job states. And I said our batch workloads are slowly transitioning to like a Kafka plus Nomad services kind of infrastructure, which is proving to be a pretty powerful kind of combo for doing a lot of this data processing. We're moving heavily to, I said, to services, making a lot of use of service discovery. And I think the previous speaker from Verizon was talking about this. It works great until you have to interact with the outside world, right? So, somebody ships a bunch of services, and now they have to speak back to on-prem, like some guy at a desktop on-prem, or they have to speak to the internet, or the internet has to speak to them. Then there's this sort of edge effect, right? And you have to do some sort of proxying between the two to translate the internet into your sort of bigger Nomad cluster. And just like the speaker in Verizon was discussing, we have a very similar kind of way of dealing with that we have this proxy layer that people can spin up that sort of acts as an interaction point between things like an ELB and our essential Nomad cluster. If we want to sort of take that further, we do need like a little bit better integration there. That's kind of a bit of a wart on this thing. Better integration between load balancers and security groups, all the networking features of these providers. But for now, the main goal is data processing, and it's working gangbusters for that. So I'd say, the outstanding issues for us are, the ACLs. I know that's, something that everyone's aware of. I don't really need full multi-tenancy. I mean, I came from an OpenStack background before this. I sure as hell don't want that again. But we do need more tighter control over what everything is allowed to speak to and the jobs that an individual is allowed to speak to. We had to, or will have to, hack around a little bit with Docker driver to incorporate a lot of our security extensions, which obviously I'm not going to talk about. What was the other thing? We're looking to, one of the things that really appealed to us when we started looking at it was it seemed really straightforward and logical on how to extend the drivers, right? So obviously if we need to, put some of our own features into the Docker driver, that still looks pretty straightforward. You just look at the code and it's like, well, yeah, I can see exactly how I would do this, right? It's not opaque at all. And to that point, one of the features we really liked about it was we are able to incorporate some of our more exotic hardware, so we could use Nomad to schedule on things other than just a VM with some compute capacity, right? So VM with some, or hardware with some, exotic hardware added on, which essentially means custom resources and things. I would say the other are probably our main just sort of nasty bit right now is the image cleanup. So essentially how that works is you just look for an image make sure that that image isn't running right now and hasn't been run recently, and then just whack it. And that's actually fine for our use case because, like I said, our compute capacity is very, very bursty. We're going up, down, up, down, up, down. So any individual node doesn't live for very long. So in actual fact, it's okay, but it's not perfect. And we're working on better integration into Vault, and you heard a lot about that this morning. So that's about it. We did this thing. It works. It was actually pretty successful. I don't know, how many millions of containers we ran through this thing, but it's a lot. It's a hell of a lot more than one. But the important point to us was that essentially the containers per second, right? As you can see, that's the key number for us. We did POC some other scheduling systems, most notably Kubernetes and a couple others, and we weren't getting the scheduling rates we need. They weren't able to feed our compute capacity as quickly as we needed, so that's why we went with Nomad. We are in the process of moving off our internal schedulers, which still do a lot of compute for us, onto this platform. And we're able to basically optimize or route all our compute now based on requirements provided by user in things they can understand. So they want proximity to data or whatever. We can actually take that, do a cost analysis on where it should be run, and push it out, which is kind of cool. So that's it. We're scaling this up even further in the coming months. Thanks.